The South Pacific Ocean covers over 30 million square miles. Deep within this expanse lies a region disconnected from terrestrial influence. It is known as the Pacific Pole of Inaccessibility, or Point Nemo. Located roughly 1,670 miles from the nearest landmasses, Ducie Island, Motu Nui, and Mare Island, it is the single most isolated coordinate on Earth. 64 years before modern satellites calculated this exact location, the author H.P. Lovecraft published his 1928 story, The Call of Cthulhu. In the text, Lovecraft provides exact coordinates for his fictional sunken city of Rlyeh, 47 degrees 9 minutes south, 126 degrees 43 minutes west. The statistical probability of selecting a random coordinate in the Pacific and hitting the most desolate patch of ocean on the planet by chance is exceptionally low. This mapping shows the actual oceanic pole of inaccessibility, pinpointed in 1992 at 48 degrees 52 minutes south, 123 degrees 23 minutes west. Later writers moved the fictional coordinates to 49 degrees 51 minutes south. Both literary coordinates tightly cluster around the actual pole. This geographical alignment anchors Rlyeh to a specific geophysical locus. It provides a localized coordinate for environmental monitoring and scientific scrutiny. This photograph captures the deployment of scientific instruments used by the U.S. National Oceanic and Atmospheric Administration. During the 1990s, NOAA utilized a network of equatorial sensor arrays to monitor deep-sea anomalies. This spectrogram tracks an event detected in the summer of 1997, now known as the Bloop. It was characterized by an extreme ultra-low frequency and a massive amplitude spike. By comparing its signature to known sources, we can see that typical blue whale calls and standard tectonic earthquakes lack the sheer power and distinct frequency profile of the 1997 event. It was loud enough to be captured by sensors over 3,000 miles apart. NOAA's leading theory classifies the sound as a non-tectonic cryoseism. In other words, a massive icequake generated by glacial calving off the coast of Antarctica. However, the cryoseism model struggles to fully account for the geographic origin point. Triangulation places the source in the vicinity of the Point Nemo locus, far north of the Antarctic ice shelves. This raises a mechanical question. If a highly localized stressor exists at Point Nemo, the resulting kinetic energy must dissipate. We need to evaluate whether submerged megalithic structures found across the globe are structural echoes reacting to whatever emitted the bloop. The 1997 acoustic event provides a testable physical symptom. It gives us a measurable pulse to trace as we investigate global geologic anomalies. In Lovecraft's text, the architecture of Rlyeh is famously described as non-Euclidean. The sailors report incorrect shifting angles, where solid stone surfaces behave with macroscopic uncertainty.
Theoretical physicist Benjamin Tippett has analyzed these descriptions and proposed a rigid mathematical framework. He argues that the architecture itself isn't built incorrectly. Rather, the physical space the city occupies is severely warped. This three-dimensional Euclidean grid represents a flat basaltic seafloor. Tippett's hypothesis requires exotic matter to generate a localized spacetime bubble here. Introducing a dense, highly concentrated mass at the center forces the grid lines to warp violently downward, forming a massive gravity well. This environment causes severe gravitational lensing. Light entering the gravity well does not travel in straight trajectories. Instead, the vectors curve, shifting the physical shape of the grid blocks from the observer's perspective.
When the fictional sailors perceived flat surfaces as slanted and obtuse angles acting as acute, they were experiencing the exact optical distortion inherent to navigating gravitational lensing. The madness described by Lovecraft is mathematically sound. The bizarre geomorphology of Rlyeh is the precise optical result of navigating a region of extreme spacetime curvature. Optics only account for the visual experience. We must also consider how a localized spacetime bubble physically interacts with the Earth's rigid crust.
The exotic mass required to bend spacetime to this degree would exert immense continuous friction against the ocean floor, resulting in extreme lithospheric stress. This global map highlights the major tectonic plate boundaries centered on the Pacific Plate. The friction generated at Point Nemo does not remain localized. It transfers mechanical energy directly into the Earth's mantle. We can model ultra-low frequency seismic waves radiating outward from the Point Nemo anomaly. These resonance waves travel along the Chilean fault lines and propagate continuously across the globe. These ultra-low frequencies selectively resonate with highly dense crystalline rock formations. As the waves travel, they apply severe geometric shear stress to specific geological nodes far from the epicenter. If Rlyeh is a physical space-time anomaly, it operates as a global tectonic engine. The most severe geological symptoms of its existence should be found thousands of miles away, where the resonance waves strike brittle crust. This underwater photograph highlights the Yonaguni monument off the coast of Japan. It is defined by massive, stepped terraces and sharp 90-degree angles. Conventional geological consensus attributes these formations to natural basaltic cleavage and oceanic erosion over millennia. In the Atlantic, we find the Bimini Road. This image displays the linear arrangement of square limestone blocks on the seafloor, another highly debated submerged site. And in the Western Pacific, the ruined basalt structures of Madol provide a third geographic node. This documentation captures the stacked, intersecting basalt columns of the ruins. When resonance waves encounter specific basaltic lattices, the shear stress follows the natural crystalline cleavage of the stone. At frequencies tuned to the mass of the Point Nemo anomaly, the rock fractures along intersecting stress lines, forcing the specific right-angle geometry observed at Yonaguni. This mechanical relationship predicts that the rock will fail along geometric axes rather than random fractures. The existing terraces align perfectly with the predicted shear stress grid generated by the Point Nemo epicenter. These sites represent the macroscopic planetary symptoms of a localized gravity well. Their geometry is the physical result of continuous space-time stress radiating through the Earth's crust. We have a cohesive mechanical model. The isolation of Point Nemo hosts a space-time curvature capable of generating the exact acoustic anomaly detected in 1997. Redefining these anomalies requires us to view the Earth's crust as a highly responsive acoustic medium. The planet functions as a transmitter for specific stress frequencies radiating across hemispheres. The resonance lines tether the Nemo epicenter directly to Yonaguni, Bimini, and Madol. The system operates like a planetary nervous system reacting to a central deep-sea stimulus. Lovecraft's Mythos endures because it touches on a physical reality. The most terrifying aspects of our universe are the physical forces we are only just beginning to measure and understand. The megaliths of our world stand as geologic echoes of a dormant cosmic mass waiting in the deep.